A very happy morning to you all, children. And on this day, I welcome you all for learning a new chapter in physics today. Children, we are going to take up a new lesson called friction today. This is a physics based chapter where you will find it very interesting. Before going and analyzing what is friction, let us see to some of the everyday events that we notice. Now, there are some events which I am going to tell you, and just you listen to them and you give the answers. Though I may not be able to hear your answers, definitely you will get up with the right answers. Now, I take a football, I roll it on the floor. What will happen to the ball after some time? Obviously, the ball comes to a stop, isn't it? Now, when you move the ball, you give the force to it. And the force makes the ball to move in one direction. And after moving a distance for some time, it comes to a stop. What should I do if I want the ball to travel more distance? Naturally, I have to apply my force greater than the before. The magnitude of the force has to be increased. So when you increase the magnitude of the force, even now, the ball goes somewhere a greater distance than the previous and again comes to a stop. Can I make the ball to go on moving without stopping by giving the larger magnitude of force? Definitely not. However, maybe the greater the force that you apply, every time the ball will come to a stop. What is the reason for this? We will discuss later. Now, I will take up the next instant. A boy, while walking on the floor on the road, accidentally, when he steps over the skin of the banana, he slips and falls off. Isn't it? You would have seen your friends also, or it may happen to you also. So, why after stepping on the banana skin, he is falling down? Next, we'll come to the event where we change the tires of our car, bicycles or scooters every 1 year or once when it gets damaged. Why? There is a wear and tear in the tires. Also, the shoes that you wear, you replace it every year. When you see the sole of the shoes, you might see that it is being worn out because of the repeated usage. Why is that? Children, for all these illustrations, the only answer is friction. That's why I told it's a very interesting lesson to learn. So in this lesson, we are going to see what is friction and how this friction is acting on the bodies, what are the factors which makes it to move upon, and also the advantages and disadvantages of friction. Now come to the first example where I had given to you the movement of the ball. When the ball is moving in the forward direction, there exists an opposite force to it which makes the ball to stop. And this force which acts in the opposite direction, we call it as friction. Any opposing force which acts on the movement of a body, it is called friction. Actually, when we have discussed the chapter called forces, we have discussed about the two types of forces, contact force and non-contact force. While giving an example for contact force, we have included frictional force. So, frictional force is a contact force. What do we mean by contact force? One body should slide over on the other body. Only then friction will happen. So, in the case of the moving ball, the surface of the ball moves on the surface of the ground. So, there exists a contact between the ground and the surface of the ball. So, when the movement of the ball is in the forward direction, the movement of the friction is in the opposite direction, which tries to stop the ball. So, let us go in detail about this lesson, and we will also see what are the factors which friction is depending upon. So, we will go into the lessons, children. Come, let's go. Children, in this lesson friction, what are the topics we are going to touch upon? That we will see first. So this lesson friction includes the following subtopics: introduction, then what is friction, factors affecting friction. Friction is a necessary evil. Increasing and decreasing friction and fluid friction. So these are the topics which we are going to deal in this lesson. So we will go one by one into these lessons. Children, let us begin this topic with an activity. In this slide, you find two diagrams, diagram A and diagram B. Upon a table, a notebook is being kept in both of these. Now in A diagram, a boy pushes the notebook from left to right. So what will you observe when a notebook is being pushed? It moves for a distance and then it stops. Then what will happen if you do or repeat the same thing with the opposite that is shown in B? Now the boy is pushing on the red color part. Previously he was pushing the notebook on the green color part. Now the boy is giving a push on the red color part. What is the observation after he pushes the notebook? Is there any difference in between these two? No. Obviously, in both the cases, the notebook goes for a distance and then it stops. Why? What is the reason for the notebook to come to rest? And that is the question which we are going to discuss in the next slides. Now let us read the slide. Gently push your book on the table. A. You observe that it stops after moving for some distance. Repeat this activity, pushing the book from the opposite direction as shown in figure B. Does the book stop this time? 2. Can you think of an explanation why the book is stopping? Can we say that a force must be acting on the book in the opposite direction? This force is called the force of friction. Yes, in both the cases A and B, the notebook or the book goes for a distance and then it stops. So the reason is there is an opposite force which acts on the book and makes it to stop. and this opposite force which makes the book to stop, we call it as friction. Children, carefully look into the pictures which are given in this slide. You find a toy car, then on the right you find a swing where a baby is sitting in the swing and the mother is making the swing to oscillate in a direction. And in the third figure you have a boat where a man is sitting with a paddle. So let us discuss each one of the cases one by one. First, let us take the toy car. Some of the toy cars are fitted with a winding machine and some are manually moved. Let us take the second case of the car where you have to move it manually. That means you have to give a force to the toy car. When you give some force, then it moves and then finally it will come to rest. Why does the moving car comes to a stop after some time, after traveling a distance? Now I want to make that same toy car to move for a longer distance and for a longer time. What should I do? I should give the force which is greater than the previous. When I give the greater force, now also the car moves a little more distance than the previous and then again it comes to a stop. Now, can I give my force large enough in such a way that the car keeps on going and never comes to rest? Obviously, it is not. It is impossible. Why? When the car is moving in one direction, there exists a force which acts in the opposite direction which makes the car to stop. That is the reason every moving object comes to a stop after moving some time. When the magnitude of your force is larger than the friction, it moves. But at the same time, when the magnitude of the frictional force is larger, then the car comes to a stop. Now, let us take the second example where the baby is sitting on a swing. So, when the mother gently pushes the swing, it goes here and there, that is in an oscillatory motion. So, this swing you would have enjoyed a lot in your childhood days, even now also. Right, now the swing will go into oscillatory motion as long as the mother keeps pushing it. What will happen to the same swing when the mother stops pushing it? So finally, after some time, the swing comes to a stop. Isn't it? Now, can you make the swing to go on oscillating without giving a force? Definitely not. So, however much you give the force, however much greater is your force, it swings for a larger distance and finally they all come to rest. So, who is making the swing to stop? It is nothing but the frictional force and the gravitational force. Out of these two, we are going to see the frictional force. Now you may be wondering, in the previous case, the car was on the road. So, there may exist a force in the opposite direction in between the car and the road. But here in the swing, the swing is not touching the ground at all. Even then, it comes to a stop. Then where comes the friction? Yes, friction also exists in the air, which we call it as drag. Friction exists in fluids, that means in water as well as in air. We call it as air friction, which is commonly known as drag, which we will take up in the final slides of the same lesson of today's. Right? So the swing comes to a stop after some time, which is all because of friction. Now finally we will come to the case of the man sitting in the boat. So what will happen if the man stops rowing the boat? Obviously it will come to a stop. So if he wants to move further, he has to apply his muscular force on the paddle. So then the boat moves. What is the concept behind this? So as long as he is rowing the boat keeps on moving. Once he stops rowing the boat, it comes to a stop. So what is the reason? The reason is one and the same. There exists an opposite force which is in the our direction of the motion of the boat, and that force makes the boat to come to a stop. So if he wants to move the boat, he has to row in such a way that the force that he is giving to the paddle should be greater than the frictional force. So when the force is greater than the frictional force, then the boat starts moving. So in all the three cases, we have seen the body which is in motion comes to a stop after some time. So it is very clear that there is a force which acts in the opposite direction, which makes the moving body to stop, and that force we call it as friction. So friction is an opposing force. Opposing force means acts in the opposite direction and makes the moving body to come to a stop. So from the all illustrations which were explained before, we can come to a conclusion. What is friction? Friction is nothing but a force. A friction is a force which is acting in the opposite direction to the movement of the body. Then the force which acts opposite to the motion of one object over other object in contact with it is called friction. So finally, we will have the definition for force of friction. Force of friction is the force which opposes the motion of an object over a surface. The force of friction acts between the object and the surface. That's why it is a contact force. Example, a ball rolling on the ground gradually slows down and comes to rest due to force of friction between the ball and the ground. Children, let us apply the same concept on friction to a cyclist. First, you see to the cyclist diagram, there are two arrow marks. One is from left to right, which is indicated in red, and it is named as thrust from the cyclist. What do you mean by thrust? In force lesson, you have already learned that thrust is nothing but it is a force which makes the object to move. In the case of here, from the thrust makes the cycle to move from left to right. At the same time, you look at the arrow diagram which is given in the opposite direction. So which is indicated in blue color. near the tire. It is mentioned as friction. So where exists the friction? The frictional force exists between the tire of the bicycle and the road. And there is an arrow, blue color arrow, which is near his head. What is that? Air resistance, as we have discussed earlier. So the resistance of air, and we call it as drag. So when the thrust given by the cyclist makes the cycle to go in the forward direction, there are two forces. One is the friction as well as the air resistance, which acts on the opposite direction. Children, you also would have experienced the same thing when you were riding your bicycles on a windy day. So when there is no wind, your muscular force makes the cycle to go at a good speed. At the same time, if the day is windy, so however much you apply your muscular force, you will find it difficult to push yourself with the cycle forward. Why? What is the reason? It is one and the same, that is the drag as well as the friction makes it to stop. Now let us read the slide now. When we pedal the bicycle, the real wheel moves in the forward direction and the point of contact of the wheel and the land surface moves in backward direction. If we stop pedaling a bicycle, it gradually slows down and comes to a stop due to friction between the wheel and the road. So this is quite clear that when you stop pedaling the bicycle, you have to come to rest. It is only because of the frictional force which exists between the tire and the road. Children, please remember the concept of contact or non-contact force when we were dealing with the lesson force. So when we were discussing on contact force, we have said friction is an example of a contact force. So what is a contact force? For a contact force, the two objects should be physically in touch with the other. There should be contact with one body with the other body. Then only we call it as contact force. If the force happens when they are physically not contacted, then it is a non-contact force. Friction is an example of contact force. So recall all the examples which we have told while we were discussing about the friction. First, let us take the case of the ball. Now the ball is, when you kick, it moves on the ground. So there exists a contact between the surface of the ball and the ground. So it is a contact force, and that's why due to friction it comes to a stop after going a distance. Now take the case of the cyclist. In the case of the cyclist, the contact is between the tires of the bicycle and the ground. So there is a contact exists between the tires and the ground. Therefore, it is a frictional force, which is again a contact force. And let us take the example of the torque car, which we have discussed earlier. So the wheels of the car are moving on the ground. So they are in contact with the ground. Therefore, it stops for a distance due to friction. So friction is purely a contact force. So all these examples reveals that friction is a contact force. Now, what are the factors affecting the friction? Friction depends upon two factors. One is nature of the surface in contact, whether the surface is smooth or whether the surface is rough. Secondly, how hard the surface press together. So it is a contact force between two objects. How the first object keeps forcing itself on the second object, and that is the second factor on which it depends upon. Children, we have seen what is friction, and now let us see how the force of friction exists between the two surfaces which are in contact. So already we have seen that friction is a contact force. So one surface, if it's in contact with the other surface, then friction exists. So friction exists between two surfaces which are in contact. And how? It is all due to the irregular or uneven surfaces. So both the surfaces are not smooth. Both the surfaces which are in contact are rough, in the sense they will have interlocking ups and downs. So the interlocking of the micro level surface between the two surfaces is again the reason for friction. So what happens when the ploughing of the harder surface into the smoother surface also exists in the reason for the friction. So friction exists due to all these three: irregular, which is uneven surfaces; interlocking of micro level surface between the two surfaces; ploughing of the harder surface into smoother surface. Children, on this slide you find an activity which makes you to understand on what factor this friction is depending upon. Now, in this picture, you have two pictures which is on the left and the right. Now, the experimental setup is as simple. You have to place an inclined plane. An inclined plane can be even your writing pad. So, keep a writing pad upon a raised surface as shown in the figure. Now you can see a red color mark on the writing pad. Why it is that, I will discuss to it. In the left side figure, a glass plate is kept closer to the writing pad, and on the right side, again one more writing pad is kept in contact with the inclined writing pad. Now the experiment is starting like this. Now you take up a pencil which is cylindrical in shape and keep the pencil upon the red color mark. Now allow the pencil to roll down. So after rolling down from the pad, first then it will reach the glass plate and it goes for a distance and then it comes to a stop. Now measure the distance from the writing pad till the pencil stops. Now repeat this experiment by replacing the glass plate with your writing pad. Though I have shown you two different diagrams, the experimental setup is one and the same. In the first case, you are doing the experiment with the cylindrical pencils on the red color mark and allowing it to fall. So as it is inclined, it will move for a distance and it will come to a stop. Now measure the distance from the writing pad till the pencil stops. Now repeat the same experiment by replacing the glass plate with the writing pad. Now here also the pencil rolls down and moves for a distance and comes to a stop. Now compare both the distance travelled by the pencil in the case of a glass plate and in the case of the writing pad. So the diagram itself, it is indicating that the pencil which is placed on the glass plate travels for a longer distance than the pencil which is kept on the writing pad. So why is this? It is nothing. The reason is the glass plate is smooth and the writing pad, when you touch the writing pad surface, though it seems to be smooth for you, when you observe it under a microscope, there will be lot of ups and downs on its surface. So when we compare the glass plate with the writing pad, glass plate is smoother and the writing pad is rough. So any object which moves on a surface of smoother surface will go for a longer distance. So what we can conclude from this experiment? Friction is less when the surface is smooth. When the surface is smooth, the friction is less. So when the friction is less, the pencil travels for a longer distance. Now read the slide. A pencil is made to roll on a glass plate. The same pencil is made to roll on a writing pad. The pencil moves a larger distance on a glass plate. Hence, friction is less for smoother surface. Here is an example where a boy is playing in the park with the two slides. Observe the two slides. The slide which is on the left is a metallic slide and the slide which is on the right is a cemented slide. Both the slides are inclined to the same angle. That means the distance travelled by the boy from the top till the down, it is one and the same. When the angle is the same, the distance will be the same. Now, when the boy is playing with the metallic slides, he slides very easily and he reaches the bottom in a quicker time, in a less time. On the other hand, when the boy plays on the cemented slide, it takes a longer time for him and also he finds it difficult to move from top to bottom. Why? What is the reason? The metallic slide has a smoother surface and that's why the boy is able to slide from the top to down in a less time and he enjoys his slide. On the other hand, when the same boy is sliding on the cemented slide, since the surface is rough, he finds it difficult to slide first and it takes a longer time than the previous. Not only that, when he slides frequently on the cemented slide, his trousers are getting damaged. So, this gives a conclusion: rougher the surface, greater the friction. So, when the surface is smooth, friction is less. When the surface is rough, friction is hard. And that's why, that is the reason now you can see why you have to exchange or replace your bicycle tires when you go frequently on a harder surface. We will discuss about this in later. Children, let us begin an activity for studying the friction. Look or observe the picture what you see in this slide. The girl is trying to pull a block with the help of a spring balance. What is a spring balance? Look at the spring balance. A spring balance is an instrument which gives the measurement of weight of an object. Now look at the same spring balance which is above the left side of her. We are trying to find out the weight of the spring balance. A spring balance contains two ends, one with a hook and the other with a handle in the shape of a ring. Now, the object whose weight has to be found, the hook has to be suspended with the object, and then we have to lift the spring balance using the ring. So when we lift, what will happen? The spring inside the spring balance stretches, and at a certain moment we can able to lift it up, and the reading which is shown by the pointer indicates the weight of the block or weight of the object. The weight of the object is nothing but it is the force. So the force required to lift the block is nothing but the weight, right? So based on this information, let us do an activity. To do this activity, you need to have two blocks, one with 1 kilo and the other one with 2 kilos. Now, we have to tie first the 1 kilogram block to a spring balance, and it has to be kept on the table. Now, we have to try to drag the 1 kilogram mass or weight towards the spring balance in such a way it begins to move. At the time when the block begins to move, note the reading on the spring balance. Now repeat the same activity with 2 kilogram block. Now what will you observe? Will the reading change? Yes. Supposing if you are using 1 unit on the spring balance for a 1 kilogram, then it will be 2 units for the weight of 2 kilograms. Okay, so what does it mean? The force required to move the object varies with the weight. More the weight, more the force is required. So that is the result of the above experiment. Here is the next activity with the same blocks and with the same spring. Now let us take a 2 kilogram block and keep it on the table, and as we did before, let us try to drag the block towards the left. Now we have to note down the reading when the block just begins to move. Let us suppose on the table we have the glass. So this 2 kilogram weight has to be dragged on the surface of glass. For example, you see the table. On the glass, if it requires, let us suppose it requires 2 units of force. Let the reading shown by the spring balance be 2 units when the 2 kilogram block is kept on a glass surface. Now next, you remove the glass and keep it on the wooden surface of the table. So you are repeating the second experiment by removing the glass. Now try to drag it. Now note down the reading shown by the spring balance. Now it will be 3 units. Now again you repeat the same process by spreading a woolen towel on the surface of the table. So the block, 2 kilogram block, has to be kept on the woolen towel or a bed sheet which is spread on the table. Now begin to do the same experiment, try to drag it. Now what do you observe? The reading on the spring balance is 3.5 units. Now observe, when it was on the glass, it was only 2 units. When it was on the wood, it was 3 units. And when it is now in woolen cloth, it is 3.5 units. You may be wondering, we are using the same spring balance and the same 2 kilogram weight. Then why is the reading different? The reading is different because the surface is different. First we kept it on the glass, then we kept it on the wood, finally we keep it on the woolen towel. So friction depends on the nature of surface. So by this experiment we come to a conclusion: friction depends on the nature of the surface. Children, this slide gives you the second factor on which friction is depending upon. Harder the surface, more is the friction. That is the concept. So 2 blocks are being kept. This is similar to the experiment where we had done the 1 kilogram and 2 kilogram mass being pulled with the spring balance. There we have seen, more the mass, more is the force required. In the same way, here is the first block, which is its size and mass is greater than the second one, and it gives more force to the surface. So the friction exerted by it will be more than the second one because the size is small, its mass is also small. Children, we have seen in the previous slide, when the surface is rough, friction is more. So we can see a practical example for a cyclist. This cyclist, let us suppose he is moving on the surfaces which are down: grass, gravel, sand, and a metal road. So he will find it difficult to travel on grass, gravel and sand because they are the rough surface where the frictional force is more. Whereas once when he comes to the metallic road, he will find it very easy to drive his bicycle. This is because the metal road is smooth. So smoother roads give less friction. Therefore, he can ride the bicycle with more easily than those rough surfaces which he had travelled so far. Children, what is the reason behind rough surfaces which has more friction? Now, to your surprise, you feel the surface of your table at home. Though it seems to be smooth to your eyes and your feeling, it is actually not smooth. When you observe the surface of your table under a microscope, you will find lot of ups and downs. That means it is not smooth. So any surface which you think smooth, it is not smooth. It has more ups and downs, which we call it as interlocking. So, and when one body slides over the other body, what will happen? These irregularities fix up with one another. You see the diagram. Surface 1, it is yellow in color. Surface 2, it is blue in color. So the irregularities of the first surface get locked with the surface of the second. So there exists a frictional force in order to trying to overcome the force. So friction is a result of irregularities in the surface of the bodies in contact. When one body is brought into contact with another, the irregularities on both the surface get interlocked. The interlocking of these irregularities of both the bodies give rise to friction. So, to move any of the bodies, force has to be applied to overcome the interlocking force. So that's why those surfaces which are rough, they require more force to get to move upon. Children, now we have come up to the end of today's learning process. Today you have learnt about friction and the reason for many observations that you see in everyday life, like slipping on the banana peel, and you have to be very cautious when you are walking on the mopped road or mopped floor, especially in public places like hospitals. So there is a signboard kept there, and so what is the reason for that signboard? Now you must be able to understand. Now we will extend the lesson in next week's class. So until then, goodbye to you and take care and be safe, children. Goodbye.